Hello everyone, welcome back to my channel Clinical R Insights. So in this video we are going to learn about the regular expression, also called as regex in R, with one clinical example. Regex is very important in clinical data cleaning, especially when working with SDTM, add-ins, lab data and adverse event. So I will explain everything step by step using a one simple data set so that even if you are a beginner, you can easily learn or follow along. So let's start. First, what is regular expression or regex? So a regular expression is a simply a pattern that help us search, match, extract, or replace text. So instead of writing multiple conditions, regular expression allow us to work with text in a very efficient way. So it is very useful for clinical programming, for lab identification, clinical cleaning subjects, extracting visit numbers, search adverse events, standardizing text variable. So yes, so let's jump to our studio so that we can learn this concept with very simple example using clinical data sets. So let's start. So this is my R Studio screen. Hope you can see my screen. With RM command, I cleared my global environment and my console is also completely clear to work. And so I created one simple data set in which I used use subject ID, param CD, and this is a Adam data set with only three observation. It's a BDS type kind of data structure from Adam, in which I have use subject ID, param CD, visit, AE term, and LB test, in which I used LB test and I'm giving three kind of different tests. So I'm saying like I don't want any character variable to be in factor form. That's why I'm saying strings as factor is equal to false, because I don't want my character variable to be in like factor form in the output. So just run this data and see. Look, these are my five variable I have in this data set and the three observation I have, because I created three view subject ID. So we will work on this data for understanding the regular expression concept, because it's easy for to understand this concept for in a little like small data set, because we can easily identify the difference what we are doing. So let's start. So first is grepl. So grepl and grep, we have two kind of function. So what is the difference between grep and grepl? So I will show you with one example. Let's start. We will use this data set to understand this concept. Okay. So just wait. Yeah. I'm applying this function grepl on. So I want to find wherever this word is. So basically, we are matching or identifying this word in our data set in this variable. Here we have only the three observation. That's why we can easily identify, okay, these two have this uh, uh, word, so we can easily identify. But if let's say we have thousands of observation, then it's very difficult to find wherever this word is present. So we can use grepl function to identify how. Let's give it in a string, because this is a string we want to find. Okay, and we have to provide the data set, right? Which data set you want to use for this. Just take this and you have to give dollar symbol, because we have to subset this variable from this data set. So I already made one video on subsetting, how we subset our data set. If you want to take a look, you can see my that video, because I explained all the subsetting method for data types in R, for vectors, for list, for matrices, for data frames. So you can take a look so that you can easily understand how we subset our data. So now run this. I already said that we are working on a grepl. I'm finding this string in this data set in this variable, right? Just run. It will give you in a true or false in a logical way, right? True and false. So first, yes, we have in my first observation, I have this word, yes, that's why it's showing true. In the second, yes, it's true. And in the third, I don't have, that's why it's showing false. So this is the function for grepl. So what is the difference between grep and grepl? This is now I'm just copying this to show you the difference between grep and grepl. This just remove this and run. It will give you index. Wherever this is true, it is giving us index. Okay, first observation, I have this. Okay, this is the observation it is showing. Second, yes, true. But in the third, we don't have, that's why it's not showing anything. But if you uh, see, this is better. grepl, because we are getting in a true or false form, which is easily identifiable. So in clinical domain, we use grepl very commonly instead of grep. So one more example I want to show you in this. One way is this, that you are directly applying, and one way is if you want to extract only those observations from this data set, only those subject who has this aminophosphatase in their LB test. So we can extract easily by using this method. How? First, I am just using this data. By subsetting data set, we will get all the observation that has aminophosphatase. So I'm just passing this, just copy paste we can do. This complete this just, and but we have to specify the comma because this is for observation subsetting. Right, we are subsetting the rows, we are not subsetting the column, that's why we are leaving it blank after the comma. So this is the way we subset our data frame. If we want to subset our rows and we want all the column in our output, just run this. Look, we are getting only those observation which has aminophosphatase in a lab test. uh, in a lab test, all the observation that has aminophosphatase, we are getting these two output in the, so that we can work uh, again for these observation. But let's say if instead of grepl we apply, in this case if we apply grep, only grep, not grepl, it will give you the same output, no difference. If you are working, you want to extract the observation from a data set, you can use any grepl and grep, no difference. Both output is same. But if you want to like you want to do QC, quality check for your data, just in console. Now it's depend on you. You want your output to be in logical form, true, false, or you want your output to be in index form. So you can easily do that, and this is very useful. This is very useful for QC purpose. We usually work whenever we are working in a clinical data set, in console we can easily check, like, okay, wherever this aminophosphatase or any string is present, if you want to check, you can easily check. So this function is very important. So the grepl and grep, any function you can use according to your requirement. So done. Next is case insensitive matching. So let's say you have thousands of observation in your data set, and aminophosphatase, somewhere you found like it is in a lower case and somewhere it is in a upper case, or maybe in prop case, or in any case. So you can easily do that with grepl, because we have one argument in this. We can easily do, just copy paste, just do this one. Okay. Uh, okay, we can use this example because here we have headache in a prop case and headache in a lower case as well in this because we are looking for the string. Whenever we pass headache, so it will give this as well because it has string in it, right? Headache. So we can use AE term as an example for this case sensitive. We can use this. For that, I'm just saying grep and grep L we can use. Any grep also you can use. Um, I'm saying, okay, let's go for the lowercase headache. And I'm passing this string to find in this data set. Let's go for the copy paste. And I'm saying, okay, I'm looking in which variable in AE term, right? Headache is in AE term. I'm subsetting AE term now. Previously, I subset the lab test because aminophosphatase was present in this variable. Now I'm setting the AE term for adverse event like headache. So just say ignore this. This is a function. This is an argument in grep L. Just use this and say true because we are ignoring case. We don't want our search to be in case sensitive. Just search. Okay. It's showing we passed the lower case, right? We passed the lower case headache we are looking for. Ideally, it should give this one only, but we are getting true for first as well because we said we don't want to search headache as a case sensitive string. So we are avoiding by using the ignoring case. And if you want to get the all the observation uh, wherever this headache string is present, just copy paste and subset this as we did before. Square bracket and pass, and we want all the column, just leave it blank for subsetting and run. You're getting all the observation that has a headache in their AE term. So you can subset your data with using this method. If you want the observation, if you want to you just want to check whether this headache is present or not, you can use this. Or if you want index, you can use grep. So these are very important function, and ignore case is very important for because in clinical domain we usually have lot like thousands of observations. So with this we can ignore any we can avoid any case sensitive things. So it's very good. So next regular expression function is like G sub. If you want to substitute something, if you want to replace some text with something else, let's look for the example G sub and this. Let's say this hyphen. You can see. I'll show you this. If you have this hyphen in between your subject ID, right? In between this, you have one hyphen. If you want to remove that hyphen and change it to blank, I don't want this hyphen, right? I want to remove this. So how we can do by using the G sub in that I'm saying, okay, replace this hyphen with some space. Okay, and now subset because as we did here, we have to do for uSubject ID as well because we are working on a uSubject ID variable in this data set. Just run and see. We are getting this without hyphen. We removed hyphen with a space. So if you want to replace any text, so we can use this gsub, and this is often required when we want to standardize subject IDs before merging dataset. Let's say you have extra hyphen in your subject ID and you want to merge two dataset and you want to make both the subject ID in both the dataset similar, then you can use this gsub for changing and or modification in your data. So this is very good function. So next is extract number from a text. Okay. For extracting something from a text, we need one function. We need one package, that is string R from Tidyverse. Tidyverse is a uh, uh, universe kind of thing with which has many packages. String R is one of them. So it's very important if you are working with strings. Let's say if you want to extract something, if you want to replace, string R is very important package to work with string change or anything you want to modify the string. Then string R is a very important package. For this, I'm just loading my string R library. Sorry. In that I already installed Tidyverse and StringR. So if you haven't, you have to first install the Tidyverse package. In that you can call the StringR package. Just call. Now how to extract. There are so many functions are available in StringR. Uh, so for extracting number, I'm using str_underscore extract. Yeah, this function from string I'm using. In this I'm saying, okay, what we are extracting first. We are extracting this digit for visit. Let's say we want to create one variable visit num. Okay, so instead from visit we want to create one variable visit num. So we want these numbers to be in our new variable. So how we can extract with this function str underscore extract, because this is a string. You can see this is a string, right? All these are string, and now from string we are extracting only the digits, numbers. So in SAS we use keep digit function. So similarly we can do in R as well. Now similarly dataset name, and I want but uh, I have to work on visit. So I'm subsetting visit from clinical underscore data. Now I have to apply some regular expression. So for that I'm using two backslashes D and plus. This is the one backslash D plus. This means we are extracting one digit or more. If there is a one digit, let's say 4, extract that. Plus means, let's say I have 12. I have 12, right? In, yeah, I, uh, backslash D means only the one digit. Plus means if I have 2 or more. So this is the complete regular expression for extracting the digit, whether it is one digit or more. You can extract it. And why we are using the two backslashes? Because this is one first black backslash is for like escape character. R doesn't understand this, right? What is this? To avoid this confusion, we have to use two backslashes to tell SAS, okay, this is a regular expression we are using. So by this, we can resolve this. Otherwise, if we use only the first, only the one backslash, it will not resolve this. So just run this and see. Okay. In first observation, we don't have any number, right? So it's giving any. And in two, we have 4 and 12. We can easily extract and keep this uh, value to our new variable, that is visit n. So by this we can create visit n variable with visit. So str extract is very useful function for creating this variable. So you can explore this better, because this is very this is mainly a regular expression, right? We are telling R, okay, we want just a digit, whether it is a first one number or a two number. Basically we are extracting the numeric part from a string. So basically this is very useful for the creation of a visit in Adam dataset. So next is start with. We use caret symbol for this to uh, like to identify any character um, in that. So we use this caret symbol. How we can do? Let's go look for the example. In that I'm just creating one grep. In that I'm saying grepl. Let's go for the grepl instead of grep. In that I'm saying if I'm using caret symbol and I'm saying capital letter. Okay. Look for this param cd we have. In that we have ALT, AST and HGP for hemoglobin. So I'm extracting only those observation which is starting with any character which is capital A. Okay. You can ignore the case as well if you have other if your data is case sensitive, so you can use that. So I'm just using caret symbol A and I'm just subsetting my data with param cd. Okay, where is the param cd subset? We can just copy paste to avoid writing again and again. Where is okay? Okay, I need to write again. Okay, let's go for param cd. Clinical data dollar symbol, and I want param cd in my this. Just run. So wherever our observation starting with capital A, it is showing true. Okay, this is for true, and this is true, and this is uh, false because we don't have any letter starting with A. So basically, caret symbol is used wherever you want to extract your data that is starting with something, some character. Okay, so you can use this. So if you want to extract all those observation which is showing true, right, you can just do. So clinical data in that square bracket, just copy paste this statement and put inside this. And we want all the variable. If you want to extract only particular variable, you can use it. If you want to, let's say you want to extract only the u subject ID, just could write quotation mark and write u subject in u. Let's say for the u sub g ID. Okay, now just okay. These two u subject ID has A in the param CD that is present in the starting of the characters. So this by this we can easily uh, we can use this for QC things. Let's say if you want to see how many test is test is starting with letter A, or how many tests are there for, let's say, liver function test, ALT, AST. So we can easily do that with this grep and this caret symbol and looking for character. Okay, done. So we can use caret symbol for the starting, and for end we have to use dollar. How we can extract that? Let's say we want to extract the digit from visit. Let's say we want to create a variable that is visit n. Okay, visit n we want to extract as we did in this, right? As we did in this. This is for creating the a visit and we use this, and we want all the observation that has something number in the end. Let's say I have 4, 12 here. So we can easily extract only those observation which has some number. So how we can do? Grep L. In that I'm using digit. For digit I have to use two back. Sorry, it should be in quotation, two back and D. This is D and I'm saying dollar in the end. This dollar is for in the end I'm looking. Okay, I'm not using caret symbol because I want to look in the end. And this one backslash is for digit. One backslash and D is for digit because I want to look for the digit. And one more backslash for escape character. You have to use two backslashes if you want to look for the digit. I'm not using plus here because I'm looking for only the digit. Doesn't matter. 4 is also digit, If I am looking for the 2, it is also digit. No need of saying, okay, 1 and 2. Any digit I want in the end only. So I'm using a visit. We can use this for, as we did before. Just copy and paste here. Well, yes, we are getting only 2 observation we have in which we have number in the end. So we can extract uh, those observation which has a number in the end. So this is very useful for QC purpose as well. So you can use and you can even extract complete observation with this. And if you let's go for this one. Just paste and change this. And if we want all the variable, not only the single one, just leave it blank after comma and just oops, I think I did something wrong. Okay, yeah, this one. Now we can have, okay. These two observation has digit in the end, 4 and 5. Okay, done. Now next is or condition. So let's say I have param CD. In that I have two observation which has ALT and AST. Let's say you have thousands of observation and you want to extra only those observation which has these two tests. So you can easily do that with this or condition. I'm using grep and I'm applying some condition. Here I'm saying ALT or I'm saying AST. These two tests I want these two only those observation which has these two tests I want the output. Okay. For that I'm just subsetting the parameter. We can use this param CD. I want to subset. So I'm just using this. Just run. We have two observation out of three which has AST or ALT. If I am saying and, then it will give nothing because we don't have any observation which has both ALT and AST. So for that, only or condition will work. That's why, or you can easily use and. If there is a two things like you are looking for something AST and only those operators which has AST and ALT both, you can use and operator in between this and you can look for your search. And if you want only those observation, you can easily do that with this. You can subset your data and put inside the square bracket and you will get observation like this. So we can apply or condition very easily for subsetting or we extracting our data. Very useful for when you are selecting multiple lab parameters. So it's very useful for ADLB data set when you are working with ADLB. Now coming to the word boundary. Now we are applying some boundary to our search. How we can apply? Let's grep. In that I'm saying, okay, two backslashes B, it's lowercase b. So then I did the uppercase. Grep, two backslashes B, space, two backslashes B. So these are the format for word boundaries, setting the boundaries between these for boundary. So we are setting the boundary. One is for escape character and slash B is for regular expression. So now I'm saying I want to extract the headache, wherever headache is. Only that word, particularly headache. And I'm ignoring the case. I'm applying this. I will get the two observation. I don't want trailing spaces, so just no space. So for that, I'm subsetting which data? AE term, right? Okay, let's go for this data set name and oops, let's see. Yeah, copy and paste. I'm subsetting AE term this data just one. So I have only one because I'm saying I specified only the capital H in my search. It's a very case sensitive, so you have to tell are that I want to ignore the case. I want all the observation that has uh, headache in that. So ignore case, I want to be true. Now I'm getting first entry because I use the grep. I'm getting the index. Now I want to use the grep. I'm getting true, false, true because in this you can see we have headache here and headache here. Now let's say you want to specify your search. You don't want output for the severe headache. You want just for the headache, not for the severe headache. How you can modify your search? How you can do that? grep L and you are saying I want search starting with headache. Let's say go for this. Just copy paste this. Okay, I want my search to be starting with H and end with E. Okay, now end with E. This is my uh, search starting with H and ending with this. Now subsetting this AE term. Okay, now ignore case because I want headache in any case, whether it is in a lower case, upper case, prop case. So I'm just ignoring that. So just run this. Look, for first only I'm getting the true, and for the severe headache I'm getting the false because I set the boundary or I set the particular search. I want starting with H and ending with E. Only those observation I want. So I'm getting only the first as a true and other as a, or you can see the, if you want to see the complete observation you can easily do that. Just do this and copy paste this, so you can mix and match whatever you want to search. You can easily mix and match. It depends upon what you want to search. It's very useful. It's completely a string function, so it's very useful for clinical domain. Look, only the first observation I'm getting as an output because I have only a headache only in my complete only headache only in my first observation. I'm not considering any severe headache case. So this is the word search like word boundary. This is for word boundary setup. But if you want to uh, like do your search more deep, then you can use these kind of things, mix and match. So easily you can do that. You can see that regular expressions are very important for working with strings. So it's very important in our domain. So now it's count pattern occurrence. Let's say you want to count the pattern. Let's say I want to count wherever headache is present. Okay. So how we can do that? For that I have to use function from a string R package. str count. Like these are similar to like something similar to the index, find, these kind of thing we use in SAS, right? Index we use index W, uh, index C, uh, and find we use in SAS. It's these functions are completely similar. For that also we work for string, and this as well we work for the string by using this function. So now I'm using str underscore count for string count number. Uh, I'm using, let's say, AE term. Okay, let's go for AE term. Yes, from where we can do copy on this one. Just, yeah, I'm subsetting AE term and I'm saying which string I want to count. I want to count headache. Headache. Done. Now run. We have only one. Why? We don't have, because this is very case sensitive, so it's a capital L. It's not counting this one. It is counting just this one. So if you say ignore case, then it will count the first one as well. So then it will show 101. So basically it is giving the count. Okay, on in the first observation we don't have, so it's going giving us 0. In second observation we have, it is giving us in the third observation we have, that's why it's giving us 1. Okay, with this you can easily count the pattern occurrence. This is also very useful when we do some analysis for our clinic data. Basically, this is very useful for EE data whenever we count EE adverse events. So we can use this str underscore count function. Now, uh, here we are using grepl in like as a single statement, right? We are not now I want to show you one or two example when we use these function in Dplyr. Dplyr is a package in a Tidyverse where we do all the data manipulation. So we can create a new variable with Dplyr with using mutate. So I want to show you how this function we can use for the creation of new variable with Dplyr and in Dplyr with mutate. Let's see how we can do. We can combine this function with creation of new variables. So for that I'm using this data clinical and I'm training this with a Dplyr pipe symbol and I'm using mutate for the creation of new variable. Let's say I want to create liver flag. Let's say these are two liver function tests, right? ALT and AST. I'm saying, okay, wherever these two are there, I want to flag that liver function flag as yes, and otherwise no. So how we can do that? Let's say I'm saying liver underscore apple. Okay, this is my new variable I'm creating in this data set. Okay, I'm saying I'm using if else statement from PSAR. Otherwise, we have a Dplyr if else as well. So I'm using if else. This is from base, but you can use. I have to load the Dplyr first. Okay, let's go for the Dplyr. I already installed Dplyr package because I already installed the Tidyverse. I'm just calling Dplyr because we are using Dplyr here, right? Because we call the string R only from Tidyverse. Now I need Dplyr. I have to call in my RStudio environment. Dplyr package I need for this work, so I'm just calling. Now you can use if else from Dplyr because now I can show you. I already installed, so I'm using if underscore else. This is from Dplyr, right? You can use if else from Besa or if else from Dplyr. It's your choice, but I think if underscore else from Dplyr is faster than Besa. I'm not sure, but yes, you can try. So you can use this any because all the other things are same. You can use any. So I'm using grep. Okay, let's copy from this. We have this condition, right? Just copy this because we used before. Inside this, I'm saying this condition, but here no need of particularly subsetting this because we are working on already on this function on this data set in Dplyr. No need of subsetting. Just pass the variable param cd. So it's better to write. I can show you how we can write. Okay, now this is if else, right? Now I'm applying grep so that you can easily understand instead of copy paste. Grep, I'm applying grep L, yes, L we can do. Okay, now, but what I want in my final output, I want all the tests that are starting with uh, in which we have ALT and ASC because these two are liver function tests. And I am flagging that observation wherever we have liver function tests. So just this, and we are using param cd as a variable A, A, param cd we have in our data set. So this is a condition, and if it's down, okay, if this condition is true, then say yes, else say no. If else statement close. So this is for this if else statement, and this is for mutate. All the bracket done, just run. Okay. Now in this clinical underscore data, we have created one more variable, that is liver flag. Wherever liver function tests are there, we said yes, and wherever other tests are there, we said no. So we can use this grepl function inside the dplyr for the creation of new variable as well. So we can very easily use this. Look for one more example for the creation of a visitant. Okay. Similarly, just use okay, copy paste. I'm using this data. Okay, chain, because we are creating new variable inside the previous data set. Okay, mutate. In mutate, you have to just write uh, visitant or a visitant. Let's say a. I'm creating this variable. In that, I'm saying because I want to create this variable as numeric, right? So I'm saying as dot numeric. I want this variable to be numeric, as dot numeric, and applying str underscore extract. Okay, and I'm saying what I want to extract from where. It's visit this variable from this dataset. And now no need of subsetting this dataset as we did before, like we did clinical underscore data dollar symbol and then visit. No, in dplyr no need of subsetting, just because we are already specified. Okay, we are using this dataset. In this dataset, I want this visit as a variable, but here we are this function don't know from where you want the data. That's why we specifically said okay this and dollar symbol, and we subset the variable. But here we are telling with this chain symbol that we are working with this data set and no need of specifying separately as a subsetting. Okay, now visit. Okay, what you want to extract from the visit? We want to extract two backslashes d and plus visit, whether it is 1 or 2. I want to extract that. So let's check for the brackets. Okay, this done for this, and this is for next one is for mutate, and other is sorry, this is for numeric, and this is for mutate. Just run all the bracket done. Oops, I think there is some missing bracket is there. Let's check. I think okay. I think I misspelled this mutate. Showing error. Now run. Yeah, you are getting okay. For first screening, no digit NA, and for second and third, you are getting 4 and 5. So by this, with dplyr, you can easily extract your observation according to your requirement by using the regular expression. So even for each term, as we did for headache, you can easily do that by using the filter. How we can do that? I can show you that example as well. Now let's say you want to filter your data with AE term wherever headache is present. Only those observation where headache is there, you want to filter that data, and you are not considering any case. You are ignoring the case because this is case sensitive. You have to specify. Okay, I'm ignoring that case. So how you can do that? Just copy paste that this. So for this, I'm just copying the data and chaining from dplyr and find that function from dplyr filter. This is for dplyr function. Actually, this Tidyverse data package. Tidyverse package and all the other packages inside the Tidyverse, that is Dplyr, Tidyr, Stringr. These are very important for data manipulation and data wrangling. So I'm currently working on my Tidyverse series. So stay tuned to this channel and don't forget to subscribe if you haven't already. So yeah, so that you can get the update whenever I update my Tidyverse series. So yeah, back to filter. So we are working on filter. Now we want to filter our data according to the AE prompt. grep L X L, and I'm applying this headache. Yes, okay. Control C. I'm using headache. Here I have to give the variable name AE prompt I'm using, and I'm ignoring the case. Ignore case is equal to true because I want all the observation that has headache just from this. Okay. These are the observation I am getting wherever headache is there. If you want to specify your you want this headache, you can do that with just adding the caret symbol and dollar symbol in the end, as I showed before. So you can easily do that. Just do this, and so these are all regular expressions we can use by mixing and match. Whenever whatever we want to search according to our requirement, we can change that. So to summarize regular expression are very powerful tool in R, especially for clinical programming tasks like lab selection, visit derivations, and adverse event text analysis. So we saw how regular expression works seamlessly with the Dplyr and mutate to solve the real clinical data problem. So I'm currently working on a Tidyverse series. So I already said I'm working on this series. So stay tuned to this channel. If you haven't subscribed, please do. And thank you for watching this video. I will see you in my next video. Bye bye.